In this session, we are going to discuss about master table and transaction table. In other words, we call it as parent and child tables, and also dimension table and fact tables, which are very important. If you fail to identify which one is dimension table and which one is fact table, then you cannot design a SSAS project. If you fail to identify what is the dimension table and which table can be used as dimension and which table can be used as fact, then it's gone case. So in this video, we are going, in this session, we are going to discuss about how to identify which is your dimension table and which is your fact table, and also about what is master table, transaction tables, and relationships. All the primary key tables, generally you know the definition. Primary key tables, generally we call it as master tables in SQL Server, where you will have master information. In the same way, the transaction tables, which holds the data about all the transactions that's being happening in the business, we call it as transaction tables. And in most of the cases, the master table and the transaction table will be related using foreign key relationship. Okay, and it may be like this master table is joining to this second master table, and the second master table will be joining to the transaction table. Somehow at the end, the master tables will be linked to the transaction table, and let's say this master table is having direct relationship to the transaction table. Okay, the master table is nothing but primary key table, where you will hold all the master information of the business, whereas transaction table is called as is nothing but a table which holds the information about all the transactions. Now let's take a couple of examples for the same. For master, let's take a business, banking business. In banking, what will be the master table? Generally, the master table is nothing but the customer information or bank accounts information or address information. All these things are master tables, whereas the transaction table will hold the information about the transactions of a particular customer or the transactions of all the customers, right? Let me take an Excel here. Oops, it's not moving. Some problem. So let me take the Excel. And let me clear the drawings here. So if you take the Excel, and let's say you are the owner, you are the designer of the database. You are designing a database to hold how many times a video played in a TV channel, in a particular TV channel. So how you will store the information? You will store the information in such a way that, let's say, a serial number, which will hold serial number 1, 2, 3, 4, and so on, and generally an identity column kind of, and advertisement name, and played time, and what else you will capture? Can you think of what kind of data you need to capture when you are trying to save or store the data of the advertisements played in a channel? Play time and duration, this is a good one, and rate, advertisement rate will be there. It will be different rates for different times. Yeah, peak or off peak. And what else? Think of couple of columns here. And okay, let's say this is the information you are capturing. Okay, and let's say the advertisement name is what I can say, Lyril Soap, and play time is 4:30 p.m. Okay, duration is 15 seconds, and rate is let's say 1 million, and peak or off peak, let's say it is peak. Okay, and even this one will do this one is good. Category, what category that advertisement belongs to? It belongs to soaps. And we can go for channel, which channel it played. Let's say Jaya TV. I'm not fan of Jaya TV. I'm just giving some example. And so if you observe, if you continue designing a table like this, it will go like n number of columns. It all depends on your thinking, how well you can think, and I mean, what are all the different options that you need to capture to store. I mean, to when you decide to capture the advertisement information. Now, if you see the same advertisement, if it played in some other day and date also, which is important, right? Which date? Let's say it is 25th June 2013. Okay, and if the same advertisement played one more time, let's say Liril 4:45, and duration is, you know, the duration is dependent on advertisement. So if it played in, if an advertisement is played at 3:30 and the same advertisement is played at 4:45, the duration of the advertisement will not change. It is purely dependent on the advertisement, right? So let's say this is 15, and rate will also remain the same. And let's say non-peak, and the category will remains the same. And the channel, let's say Gemini, and the date is the same. So if you observe, for two records, there are so much of data which is repeating. The advertisement name is repeating, the duration is repeating, the rate is repeating, and also the category. Why? Because all these four column information are dependent on each other, or dependent on the advertisement name. Okay, let's say some thousands and thousands of advertisements are played, and you have to capture that information. And why you need to repeat the same stuff again and again? If you know that these four columns will be repeated and it will have the same information, that information will not be changed, then will it make sense to maintain and store the information, the repeated information? Is it required to store? Is it not enough if I maintain this information only once and use it again and again? Let's say I'm creating one more table where I'm having an ID, that I'll call it as advertisement ID, and the name of the advertisement is Liril, and duration I'll say it's 15 seconds, and the last one is category, and I'll say it is soaps. So if I maintain this information separately, then in this table I can avoid few columns. The first one is, I can avoid the advertisement name, I can avoid the duration, I can avoid the category, and also the rate, right? Instead of this, what I can maintain? I can maintain ADV ID. So I'll take this ID and I'll give it here. So now if anyone asks me, okay, what are the advertisements played on 25th of June? I'll come here and I'll take the dates. Okay, 25th of June there are two ads, and these two ads are played, one in Jaya TV and another one is Gemini TV. And if we ask about the ad information, what is the advertisement and what is the duration of that, then what I will do is I'll take this ad ID, which is 1. I'll go here and I will use joins to join the table, and I will join and I'll search for this ad ID. The first one is the ad ID. So I will tell the ad is Liril and the duration is 15 seconds, and the category is soaps. So if you observe, you can maintain data in two ways. One is normalized way, another one is denormalized way. The first one what we have seen was denormalized. All the information will be in one table. The problem with this kind of storage is you have that repetitive data will be there. The data will be continuously repeated. right? And the second way is normalized way. In normalized way, people will try to split the tables as much as possible in order to make the maintenance of the table easy, right? If you see, the maintenance will be very easy here. Here you will store only the advertisement details only once, but you will use the same. Only one column will be used, which is common in between these two tables. So the storage will be very less and maintenance will be easy. Maintenance in the sense, if you see, if I want to join this particular advertisement detail, if I want to use the advertisement detail in another table, okay, I can use that advertisement here in, let's say, another table, another fact table. And I have one more transaction table where I need to use advertisement ID. I can use it. And I can repeat the same in n number of tables. Wherever I want advertisement details, I can use this ID and I can join these two using a common column, right? If I don't maintain a separate table, which we are calling it as master table, if you don't maintain it, the problem is if you maintain everything in one denormalized table, and if you want to create one more, let's say media, this transaction table you are maintaining data for paper advertisements, and let's say this transaction table you are maintaining for YouTube videos, and this is advertisements that are played in TVs, and this is advertisements that are played in movies. So in every place you have to repeat the same columns, and that too lot many times than required. So that is why the master and transaction table concept came into picture, which will help us in reducing the space that is required to store the data, and also the maintenance will be so easy, far better than maintaining the denormalized data. Let me take these drawings out, and I've given a simple example, advertisements, where you will have very less data and hence you don't get clear picture. Let's take a different example where you will see the problem in storing the data if you go for denormalized type of storage mode. In that, let's say I'm talking about banking, or let's say I'm the owner. I'm going to design a database to capture the information about the any telecom network. Let's say Airtel in India. Okay. I'm the customer. The customer ID is 1. Name is Rupesh. Having phone number 973-971-4445. And from Andhra. City is Tirupati. And let's say, what else you will capture? His pin code is 517501. And his landline number blank, nothing available. Oops, I'll give it as not applicable or something. And when he joined the network, when he has taken his connection, let's say he has taken his connection on 25th March 2010. And what else you will capture? You'll capture so much of information about, see, whatever you are filling in the application form while going for a new connection, everything will be captured here. Okay. Father's name or ID proof. ID type, let's say it is passport, and ID number, it is some XYZ. And here you will get the original information, the required transaction information, right? Let's say the information is like, and one more information is whether it is prepaid or postpaid. I'll go for postpaid. And given a missed call, type of transaction, missed call, date is on 25th June 2012. Here the Rupesh has given a missed call. To number, let's say it is some XYZ number. This is the to number to which Rupesh has given missed call. And the duration is 0 seconds. Right? It will be 0 seconds. It's a missed call. Now, first time Rupesh has given missed call, and next time he has called. Okay? And the transaction, the ID will be 2, and the remaining details will remain the same, and this time it is call. And 25th, And we also need to capture call start time and end time, right? Start time is, let's say, 4:44 p.m. End time is also 4:44 p.m. Here the start time is 4:45 p.m. and end time is, let's say, 5 p.m. Okay. We can go for so many other columns. Not only these set of columns, you will get so many other columns if you try to capture the information of a telecom transactions, telecom related transactions. Now, if you observe, this is for one missed call or one call, you are maintaining this information at the minimum, right? Imagine there are 1 crore customers for Airtel in Andhra Pradesh, and 1 crore customers on an average will make uh, 3 transactions, either missed call or message or call or receiving the call, dialing the call. Let's say on an average 3 calls, 3 transactions. How many it will be? It will be 3 crore records in one day, right? This is the number of records that you are gonna store in one day. That too only for Andhra Pradesh, assuming that there are only 1 crore of customers. Now imagine Rupesh has sent a message, SMS, to 2000 recipients, 2000 or 2000 members, or let's say 200 members. Then what will happen? The same information will be repeated 200 times, right? Agree? So if this is the case, why I have to repeat the customer name? This will be remain the same. This will not be changed. This will not be changed. This will not be changed. And this will not be changed. This will not be changed. And if you take, there are so much of stuff which will not be changed at all, right? So what I'm going to do here is I'm going to cut that information and paste it here in a separate table. Now I can save, see, 1 to some 10 to 15 columns. Let me delete it. Now if you go to the second table, the one where you copied the information, one is Rupesh, and I don't need the second one. Why? Because Rupesh record is already available. So instead of maintaining the complete information in the transaction table, which will occupy a lot of memory and which will lead to performance issue, I'll maintain the customer ID. The customer ID is 1. And let's say I have one more customer with the name Lokesh. I'll give some number, and let's say this is bank, something else, some information. Let's say there is one more customer with the ID 2. If this guy has made any transactions, any calls, then it will be stored like this. He has made a call on 25th June, same time, just like I have dialed, but the customer is 2. But the recipient number, let me change it. If you see the table, the transaction table has become very small. Most of the master table information, the data which will not be changed so frequently is called as master information. The data which is fixed over time, like it won't be frequently changed, that is called master information. And if you see the transaction table, this will be continuously changed. Daily there will be a lot of transactions that is getting added to the table. And if you take a telecom, I work with the telecom, you will get billions and billions of records in a month. Billions of billions. Nowadays, if you take any one state in any country, you will have a minimum of 1 crore customers for every network, every telecom network. They're maintaining 2 to 3 different network SIMs. They're making use of offers, whatever it may be the case. You will find at least 10 million customers per telecom network. And imagine everyone is making use of 200 SMS per day offer, and everyone is giving so many missed calls, and everyone is dialing. So how many records you will get per day? Right? There will be hell of records. Right? So if you repeat the master information again and again and again, you need some huge what we call data storage. You can't store in a simple hard disk which is having 1 terabyte or 10 terabyte. You need you need lot of memory to store the same information. And if you split the table into two, one is called as master table and another one is called as transaction table, then it will be very easy to maintain. Let's say if you observe this table, the second one, which we are calling it as master table, and if you observe, this Tirupati will be in Andhra Pradesh only, right? And let's say there is one more customer, Vinay, his number is this. He is also from same area as mine, okay, and pin code is also the same. And let's say some other information is here for the remaining. If you observe now, the pin code, the city and the state are same, and it will be repeated for multiple customers. From one area there will be some hundreds of customers, right? So instead of maintaining in the same table, if you observe it is repeating, the data is repeating. So what people will do is they'll maintain ID 1. This is Tirupati, Andhra, and the pin code is 517501. And they will make use of this ID instead of this stuff. So instead of 3 column information which will be repeated again and again, they will maintain the ID. Let's say this customer is 2. 2 means 2, Chittoor, Andhra, and let's say 5 some pin code. So if you observe here, you have splitted one big table into 3 tables, right? First, this is your transaction table where you will have all the transactions, and if you want to know who is the dialer, who is the customer who dialed this number, you have to go here, take this ID and join with this table and find out, okay, this is the Rupesh. The customer name is Rupesh and he is holding this number. And this is his details if they want. And this call, the third one, is made by customer 2. It will join with this table and it will find out, okay, Lokesh is the customer who has done that, and blah blah blah. And if they want to know the address of a particular customer, again they will come here, they will have this address key, they will go here and they will join with this address table and they will get the address of the customer. So like that they will split the tables, they will make sure that the data is not repeating, and columns are entirely dependent on primary columns. There should not be any column which is not dependent. There are a couple of normal forms which will be which you can apply. If you apply the normal forms on the denormalized data, then the output will become normalized data. So that means the one big table will be split into so many small tables, which by applying the normal forms in SQL Server. Hope you get clear picture about what is master table and what is transaction table and why we split the tables into master and transaction. And if you observe, when you say that a master table and the transaction table is having relationship, that means both the tables should have at least one column in common. In this case, what is the common column? This is customer ID. In this case, what is the common column between this table and this and the customer table? It is address key, right? So there will be at least one common column which we will use for creating foreign key relationship in SQL Server. Now this is about master table and transaction tables. And in short, the master tables is not the one is the one which won't frequently in which the data will not be changed frequently, and which will store the master information or the textual information, I can say. Textual information. You can see that most of the cases you will have the textual information, like what is the customer name, customer address, customer pin code, customer fax number, and so on. But if you go to the transaction, here you will deal with money, here you will deal with units, here you will deal with metrics. How many calls he has made, and what is the duration, how much amount I got. So you will deal with only metrics of the business. So that is called transaction tables. Now let's see what is dimension table and what is fact table. You need to identify these two types of tables. If you take any data warehouse, you will have three kinds of tables if you consider SSAs. One is dimension table, another one is fact table, and another one is factless fact table. Now in this session we will discuss about dimension table and the fact table, and we will discuss about this factless fact table in the coming sessions. I know when to explain that. If I explain that now, you will get confused, so let me take it after a couple of sessions from now. Okay, so what is dimension table and what is fact table and what is SSAS? SSAS is mainly for question and to provide answers to the questions that anyone has. If you take any business, I'm giving chance to you guys. Just tell me one business. We can take it as an example and continue. So let's go with the Tesco supermarket. And generally, if you are the owner of the Tesco supermarket, at the end of the day, you visited the supermarket just to know what happened, how the business went. So what is the first question you are going to ask to the person who is managing the store? Okay, how much sales is the question, the first question, right? How much sales, if you see, indirectly, the actual question is how much sales today. Is it correct? It's not like how much sales. How much sales means it will be, it's a generalized one. You can answer like throughout the supermarket career. It will not be like that. How much sales today, right? Let me note down the question. How much sales today? And the next question will be how much profit today? Okay. Which product has more sales? Which product has very less sales? Right? And sales by category. Which category is having more sales? Which category is having poor sales? So if you observe any of this question, this is not a single question. You will have two. One is sales and the other one is the day. You are giving answer to the second question. The answer to the second question is today. Which day, how much sales is the actual question, but you are asking the question by giving answer to half of the question, that is today what is the sales. Clear? Generally, if you take any question, you cannot inquire or you cannot analyze a business with only one question. You cannot do that. There will be two questions for sure, and the chances will be like this. Either you will ask two questions to the manager or the person who is managing it, or you will give answer to the one question and expect the answer to the second question from the other, right? If you see the first question here, you are giving the answer to the first question, that is today. Today, what is the sales? You are asking the second question to the other guy. And today, you are giving answer, what is the profit, right? In the same way, the third question, which product has more sales? Here you are asking both the questions to the manager who is managing the store. Which product? He has to answer which product and has more sales. Now here you are giving answer to the second question, that is more sales, right? And which product? Less sales. Less sales is the answer, is the metric. You are giving answer to that. I want the least sales one. And what is the product? You are asking the question to the manager. So there will be two questions, and one question answer will be your dimensions and another question answer will be your metrics, that is fact tables. Now let's see what is the first question, and what question answer we have to consider as dimension and what question answer you have to consider as fact tables here. If you take the same product wise sales, give me product wise sales. So product wise, there will be one answer for this. What will be the answer for the product wise? Let's say it will be Liril, Shintal, and tell me some other, Nivea. Tell me some products here. Not only soaps, anything else. Eggs, chicken, I love it. And what else? Milk, and so on. This is the answer for the products. Which product? What is the sales? And the second question answer is sales. Sales means, let's say it has $100. This guy has only $20. This has very poor, that is $10. This is $500 X. $200, let's say chicken $1,000, $10,000, milk $300. If you see, I asked the question product wise sales, give me the chart, give me the product wise sales. If you observe, I'll get two answers. What are the products list and what is the sales amount? And now this is nothing but a group by query, right? Select product name, comma, sum of sales from fact internet sales or some sales table, inner join products table, group by product name. And if you observe the same, this data, the first one will be coming from some table like this, master table. And this data you will get from transaction table. And you will join these two tables, to get this information. Right? In the same way, if I ask you, give me top 5 products which is having good sales. Again, I'll get 5 product names and top sales amount. What is the amount, right? And if I ask the question, which customer, give me customer wise sales, then the output will be list of customers and what are their sales. So these customers will be coming from master table, the sales will be coming from transaction table, right? So if you take any example like this, it will be a combination of two queries. What or which or when. Okay, this is first question. That why questions are W questions will be there, right? Why, when, what, where, all these things will be one part of your question. And the second thing is how much, how much. That is the second part, right? The second part question, the second part answer will be from your transaction table, and the first part answer will be from your master table. And all the master tables or all the answers which you will get for why, when, where, how, not how, why, when, where, which, that is your dimension tables. And how much sales or how many units. So the answers for this one will be coming from transaction tables, and hence those tables are called fact tables. Okay. In short, dimension tables are nothing but master tables where you will have textual information. And fact tables are nothing but transaction tables where you will have the information about the transactions. Clear? Keeping this in mind, you should not blindly go and create dimensions for all the tables, all the master tables in the database. What you have to do is you have to think, if I am the business and I have given a requirement, I want to see color-wise sales. So obviously what I have to do is color-wise sales. Okay. So color will be my dimension and sales will be my transaction. So sales I will get from fact internet sales table in AdventureWorks database, and color I will get from dim product table in the same database. So the color table, that is dim product table, will become my dimension table, whereas fact internet sales will become my transaction fact table. So if you take another example, I want to see customer wise sales. So obviously customer wise, so customer will become your dimension table, whereas sales, where you have the sales information, will become your fact table. And if you want me to present it in a different way, there will be two things in a question, in any analysis part. How you want to see data, what data you want to see, right? What data you want to see? I want to see metric data. I want to see sales data. I want to see sales units. I want to see sales amount. I want to see count. These are my metrics. This is what I want to see, or these are the metrics which talks about my business, which says that whether my business is good or not. Generally, what decides a business is growing or diminishing? Generally, what decides? The metrics like sales, how many units sold, right? For example, everything cannot be decided based on sales. Let's say if you ask me a question like whether a temple is a good one or a famous one or not, then I can answer only by seeing the count of people who are coming. So the count, right? The revenue, all these are metrics which will talk about your business growth or dimension. So this is what I want to see. This is what any business guy want to see to compare with their competitors. And the second question is how they want to see the same metric information. They want to see the metric information date wise, quarter wise, year wise, customer wise, product wise, location wise, geography wise, and what else? Category wise, subcategory wise, and what else we have? Employee wise, which employee performed good? Had more sales, right? So if you question like this, then you will get answers and you will easily find out what is your dimension table and what is your fact table. And there are a couple of blind marks which you can keep in mind to identify the fact table and the dimension table. The first one is for dimension table. It is a master table. It should be a master table. The second thing is it will have textual information like customer name, account holder name, or caller name. So all this in textual information. And if you see, it will have the data for your question, how you want to see the data, right? It will give you a one dimension, like I want to see customer wise is a dimension, month wise is a dimension, quarter wise is a dimension. So it will give you one dimension of seeing the data, of seeing the metrics to analyze your business. Now, if you take the fact table, the first thing is it should be a transaction table, the first and foremost thing, and it should have not repetitive information. It should have all the transactions. We cannot call it as repetitive. A field can be repetitive, not the complete row, right? So it will have the sales information or the transaction information regarding your business, right? And it will have metrics, the main thing. The metrics like sales amount, you will find integer columns. The first one is having textual columns, the dimensions, whereas the fact tables will have integer columns. Integer columns is the main key which will talk about your business, right? How your market, how the market is. So business analysts or business guys, they want to see how a particular product is performing, where a particular product is performing good, or where a particular product is not performing good, or how is the market compared to my competitor. So they will take these questions, how and what metric, okay, and they will get the answers and they will compare with their competitors, and then if they are not performing well, then they will think about a better strategy. They will go for better strategy and they'll give some offers. They'll try to grab the market. They will try to occupy the market wherever they're not performing good. So to do that, they need some solution which will give the results very quickly. And this SSAS projects is one of such solutions which will help the business to analyze their market, their business in very, very less time. Is it clear now? Okay, this is super good. Now, let me erase the drawings from here. Okay, let me take the pen. Now I'm going to ask you guys what this table will be, a dimension table or a fact table. Don't look at me in a different way saying that, thinking that, okay, man, you have brain or not. There is a dim at the start of the table name, okay, and you are asking me the question. So that's why everyone is replying quickly, so quickly, that is a dimension table. Okay, fine. Now, let me add a couple of more tables and I'll ask you what a table is. Okay, I'm adding tables. Let me add everything. Okay, I will arrange the tables. Now let me go to the same dim product table. Okay, what is this table? A dimension or a fact? Only Kranti answer to that. Okay, dimension. Now I'll take this table in SQL Server. Okay, you are saying this is a dimension table, dim product, right? Let me connect to that. Select star from dim product, right? You are saying this is dimension table. Why? Because this is a master table. That is one check, and the second thing is this is having textual information, right? Now I have a scenario. I'll tell you the scenario. You just tell me the query. Okay. I want to see how many products are there per color. For every color, I want to see the count of products. You know, this is the this is the product name. Okay. And I want to see color wise products. If you see, this is color. If you take this first 10 rows, there are 5 NA color products and 3 black color, no, 4 black color and 2 silver color. And I can get the count, right? So now I want a query to get the count of products per color. How can I write the query? Cool. As you said, select count of any one column. If one I can give, comma, color from dim product group by what I have to give? Color. Right? I don't need to filter by. I just want to all the color products. Okay. I will also give order by. Order by count of 1. That means the top color will be on top. So if I execute this, it is giving me gray has only one color, one product with gray color, four products with white color, 7 products with silver and black, and so on. 254 products which is not having any color, not applicable color, and 133 products with black color. So here I am getting metric. What is my metrics here? The count will say which one is having more colors, which color, sorry, products are manufacturing in which color, right? So number of products or number of products is my metric here to identify that which color is the booming one. If everyone is going for black color products, that means there are so many guys who are buying black color products, right? You can make use of this. This is a metric. Now, if you see, the metric is from dim product table, and also the textual information is also from the dim product table. So can you say this is a dimension table now? Very smart answer. Looks like a fact table. Actually, there is, see, the general formula is if it is master table or if it is having textual information, people use it as dimension table. And if it is not having master information or textual information, and if it is having fact information or metric information, then we will use it as fact table. But in real time, these all depends on the requirements. If they ask you to generate a report, I want to see color-wise products. How many products are there? Not product names. I want to see the count of product, the output of the same query, whatever I have executed here, right? So if you want to generate this report, what you need? You need just dim product table, which will act as both dimension as well as fact, right? It all depends on the requirements. Let me give you one more example. I want to see which category has what products, how many products per category or per subcategory. What I can do, count of 1 from dim product, with which table I have to join to get the category. Inner join dim product category, subcategory. I'll name it as A, I'll name it as B on A dot product subcategory key is equal to B dot product subcategory key. So I join these two tables, and if I execute the count, I'll get the complete count. And if I group by English product category name, subcategory name, then it will give me subcategory wise. If you are not good in group by statements, just practice as much as you can. We are going to use a lot of group by statements, only group by statements, nothing else. So if I execute this, it will give me what are the different subcategories available and how many products are there for each subcategory. Now what I'm going to do here is I want to see category wise how many products are there. That is my requirement. I have to show it in a report, let's assume. So what I have to do? I have to join with subcategory table, category table. And here product category key will be joined with B dot product category key. Now it will be based on English product category name, right? The group by. Why? Because I want the count based on category. If I execute this here, in all the cases, if you see the dim product table acts as a fact table here, not the dimension table. Correct? So it all depends on the fact, on the requirements that you are going to get. Then only you can decide whether it acts as a dimension table or a fact table. Okay, and not mandatory, Mr. Vikram. As you said, for a given dimension, another dimension can act as a fact. It can act as a fact. It can even the self table, the same table can act as a fact for the same. I showed you an example, color wise count. So it will be like, what is your metric? What is your requirement? What is your metric? Based on that, the call will be taken. Which one is dimension? Which one should be created as a dimension? Which one should be treated as dimension? And which one should be treated as fact table? It all depends on the requirements. So by seeing the dim product, the name, the dim before the table name, don't blindly think that this can be used only as dimension. Sometimes you may need to use this as fact table, right? But in general, 99% of the master tables will act as dimension tables, and 99% of the transaction tables acts as fact tables. Clear? And I hope if I give you a requirement, you can easily identify the dimension and the fact table now. Correct? Okay, cool. Let me put an end here for this today's session, and I will give you an assignment. Okay. The assignment is, let me stop recording. Why? Because I don't want to make these assignments as part of the training sessions. Videos, I mean to say. Okay, let me record that assignment also. Think of any business. Okay, any business of your wish, like retail, pharma, real estate, banking, finance, anything, whatever you think of, your favorite, let's say. Think of any one business, and if you are working, assume that you are working as a database developer, database designer for the same business. I need 5 master tables and 1 transaction table. You have to design it and take the backup of the database and attach the backup of the database to the mail and drop a mail to me. I'll verify it. Is it clear, or do you want me to repeat? Okay, I repeat. Think of any business of your wish and assume yourself that you are the database developer who are designing a database for that, and design 5 master tables and 1 transaction table. Think of any information. I'll give you one example. Don't take this one as I'll give cricket as example. No one, please, even gambling business, I'm fine, man. Whatever business you think of, that's fine for me. So I'll give you an example. Cricket database. If it is cricket database, the runs scored will be maintained in the transaction. like runs, is it a 4, 6, wide, bow, 2 runs, 3 runs, everything will be maintained in the transaction table. And the master tables will be like competitions, dates like year, which year the competition is played, matches is a master table, players is a master table, teams is a master table. All these are master tables for the cricket business. If you consider cricket business, and the transaction will be runs scored per ball, right? This is how you design a master and transaction tables for a cricket business. In the same way, think of any one business, either gambling or whatever you wish to, whatever you are interested in. I'm happy. I have no issues. Um, Define 5 master tables and 1 transaction table. Take the backup and send the backup to me. I'll review it by tomorrow's session. And it is very important. It's a very good practice. If you miss or if you neglect to do this, I'm not going to lose anything. Thank you guys. Have a nice day. Bye bye.